Okay, why don't we get started? Thanks for coming. Today we're going to take a look at a project that's been just a ton of fun, which is the .NET Services project. I've been pretty lucky to be there since the beginning, and I get a chance to talk about the amazing work that a lot of the guys here, Justin and others, have been working on. And just to kind of set context on this thing, .NET Services is part of the overall Azure platform, and it's a way to create a set of components that are hosted up in the cloud to build software applications. And really, what I want to do is just focus on three key things for this talk. One is I want to talk about how .NET Services are a collection of components that you can use to build into your applications to address issues around access control and application-level messaging. The second point is that it's easy to use. And I just don't mean easy to use from a developer sense. And as we'll see, it doesn't take a lot of lines of code to take advantage of these things. But because the services are hosted for you, you don't have to do setup. You don't have to do maintenance on them. You don't have to worry about how they're going to scale out. There's a lot of things that get managed because the service is up in the cloud. And Microsoft isn't the only group out there doing that. We see Amazon, Google, and others starting to use this same approach to make things a lot easier to use. Third key thing that I want to talk about is how it's all based on open standards. So if you're a Python developer or PHP, Ruby, Java, .NET, you're able to get access to these technologies. And you don't need a big, complicated Microsoft stack in order to go take advantage of it. Now, on the other hand, if you happen to be on the Microsoft platform, there's a lot of cool stuff we can do to make it super easy to use and so on. So to illustrate those last 2 points in particular, I want to kind of do something a little bit wacky. I'm going to use a whole bunch of non-Microsoft technologies that, frankly, I'm not super expert in. And so we're going to see how these other platforms can use .NET Services and take advantage of the kind of capabilities around access control and application messaging. Not only that, we'll do it live, and I'll also take advantage of some new code that guys in the audience, Clemens, Justin, and others, have been working on for future releases, and they'll be blogging about those things over the course of the next couple weeks. So we're going to be kind of on the edge here as we go through the next couple of demos, and then we'll kind of move back into some more standard stuff. So with that, let me get started showing you how you might use some .NET Services. So my sister is a chef, and she does this. She's single. Sorry, she's got no kids, and her and her husband have set up a business where they'll travel around the world and cook for people. And mostly that's a word-of-mouth kind of business, but they've wanted to have a website. And on the website, one of the key things that my sister would like to be able to do is help people design the menus. That's one of the trickiest parts of the project. So I'm not a great designer. I whipped together this really exciting web page. Let me show you that. And you know, we're obviously going to need to get some CSS help and some other things here. But we can design menus. So let's say I want to design, I don't know, the dinner menu. We'll take pizza and ice cream. And we'll drag those things over there, and we'll call that dinner. So that's the basic idea. You can go create a pretty simple menu. Let me show you the code for this thing just for a second. Nothing too remarkable here. We've got a very, very vanilla list, two lists. We've got a list of menu items, and we've got a list of that we're going to drag onto. And what we did was we used jQuery UI to make those things sortable. And sortable means that they can be dragged around, dropped, and put into a different order. And then we've got a simple form down here that when we post, what we'll do is we'll take the list that we just created and we'll post it up to the server. That's how we'll create a menu. So very standard, plain vanilla JavaScript. Notice it's running in Firefox here. There's nothing up my sleeve. Little tiny bit of CSS to make them look nice, and that's how we get the menu. Now, in terms of the code on the server, I'm going to want to collect up that form post, and I'm going to want to drop it into a database. Again, very standard kinds of things. So let's take a look at some Python code here. And here we've got the menu handler. And when we do a post, we're just going to grab the menu name, the list of items in the menu, and we're going to go then here, put it into a database item, and put it, and we'll say that we got that done. The other thing that we're going to do is we're going to let you do a get on it. So if I type in /menu/ the name of the menu, then we'll go look inside the database. We'll use a standard Python Django template, pull it out of the database, and write that thing out. So let's just see that in action. If I save the dinner, there's the dinner, and then I can go look at it. And so that pulled it out of the database. What could be simpler, right? Nothing magic there. That's just standard Python stuff. Now, one of the things about these menus is if I create a menu, I want to be able to edit my menus, and I might want to let certain kinds of people view them. So I'd like to have some access control over these menus. But my sister's website it's not some big deal. She's not going to get people to go register and come back. They'd forget their passwords. So what we'd really like to do is let people use their identities from Facebook or Yahoo or Google or Live. And we'd like to be able to provide access control on those things. And we really don't want to write a lot of logic inside of our app to have to worry about all these different kinds of open IDs versus live IDs and all those different kinds of credentials. So what are we going to do? And this is where I think things get kind of cool. The basic idea is that right here, before we go do anything and return that menu, what I'm going to do is I'm going to check for a cookie. I'm going to see if I have permission, what we call a claim, to be able to look at that menu. So I'm going to pull the cookie out. If I have permissions to look at it, great, we'll go show the appropriate things. If not, we're going to go redirect to the access control service, which is going to go handle a lot of this access control stuff for us. So the basic idea would be I'd go in here and I'd type in the name of the cookie, and I'd make it something like the text claims. But since I don't want to bore you with my typing, let me grab a little snip of code here. And I'll just walk through this quickly. So there's the cookie. We're going to get it out of the cookies collection. If I don't have any claims, then I'm going to say, hey, you don't have access. You better log in. And so we'll just redirect to the access control service, and we'll put a redirect back to ourselves. Make sense? Pretty straightforward? OK, so let's save that. Now, here's the kind of interesting thing. I'm going to just pump that thing up to Google App Engine. So there's a Python thing. Google App Engine runs Python. It's now put it up on Google App Engine. And let's take a look at that live. Up now, hosted on Google. So here's www.chefs International. And let's just go look at the menu. And let's create a quick menu. I don't know. Pizza. Well, let's see. Steak and fries. That might make a good dinner menu. And we'll call this John's menu. We'll save that. And notice that when I go access the John menu, I don't have permission yet. I created the menu, but I haven't signed in at all. So notice that one line of code, check for the cookie. I don't yet have any cookies that say that I have permission to go view or edit this thing. So it's asking me to log in. So I click on that login link, and notice it's redirecting me over to the access control service. I can log in with a bunch of different identities. Microsoft is going to supply integration with quite a few of these things. So I'm going to pick my Yahoo OpenID, and this is actually me, share and continue. And what happens is it goes and sets the cookies, and then it redirects me assuming everything's wide awake and all of these pieces that I don't really control are all working, we should get ourselves back, and I should be able to view that menu. So there you go. That's it. Couple lines of code. Google App Engine talking to the access control service. We're providing access control for Google App Engine projects. Now, let me show you kind of what's going on behind the scenes here just a little bit. I've got this crazy Viking guy. I don't know why he uses this name. He'll have to explain that. That's Todd here. And he's created an access control project for me, which is what I redirected to. And you'll notice that what Todd has done is he's created a scope, a space that we're going to have some rules about who's allowed to do what. And in particular, we've set up Chefs International Menu John, the one I just created, and we can go take a look at the rules that he's created. And you see he's set it up so that my Google account, there's an OpenID at Google, and my Yahoo account, let's take a look at my Yahoo identity, that both of those things get various kinds of permission. So the idea is pretty simple. If I come in as John at Yahoo with my OpenID, then the output claim is the ability to view. And just to kind of demonstrate how that works, let's just change that to edit. Save it. And instead of doing some complicated logout and all that kind of stuff, which I didn't write, I'm just going to do the manual logout operation, which is to remove the cookie. Say close. And let's just look at that menu again. No cookie, same logic. So what do? We redirect over to the access control service. We sign in with my Yahoo ID again, share and continue. Hopefully everything's a little more awake and faster. It sets all the cookies for me all automatically, and assuming everything's good, we should put a little spinner on here or something. There we go. Now I have edit capability. Make sense? So what's the access control service do? It provides a mapping from various kinds of input claims, whether they be identities or groups, memberships in corporate directories, to other attributes, other claims. And those things can be chained. They can do all kinds of interesting things. But as you can see, I was able to, with just a couple quick lines of code, now integrate this Google App Engine Python project with the access control service and start providing integration. Now, notice I just did a couple of identity providers. I did Google, Facebook, Yahoo, but this could be corporate directories as well. So if you had Toyota and they were running on Tivoli, we support the WS Star protocols, and so you could integrate with those things as well. Justin, who is sitting right there, has a talk immediately following this where he's going to go through in a lot more detail how all of those things work. And I'll cover some of it, but there's the expert, and we'll be going through that stuff. OK, so that's a quick, super lightweight introduction to the access control service. I want to talk now a little bit about another service that we have, which is the service bus. And here's the situation with respect to that, which is my sister's got this website. People are out there now creating menus on the website, and my sister wants to know about it. Well, she travels, so she'd like to be able to look at that stuff through a website. But she also works at home, and when she's working at home, she'd love to have the classic thing that you get, like when you get new mail, which is a little pop-up that shows up on Windows, a toast. And when somebody creates a new menu, she'd like the little toast to pop up and say, hey, somebody just went to the website, they created a new menu. So how am I going to go do that? Well, again, that's going to be pretty straightforward to do. I could go type that stuff out, but nobody wants to watch me type. So we'll grab one little tiny snip of code here. And all we're going to do, I'll walk you through this, is right after we update the database with the new menu, that's right here, I'm going to do an HTTP post. I'm going to use the standard Google URL fetch mechanism. I'm going to post to that project that my crazy Viking buddy here created. And we're going to have the payload be a standard form post payload, which is new menu with the value message, which says that it's a new menu. And if we look over here, it'll just have the name of the menu. And that's it. So we're just going to do a post up to the service bus. And the service bus is going to go send out messages to anybody that's interested in this particular event. So all we're doing here is we're using standard web technologies to post new events like the fact that a menu's been created. Now, the great thing is, this means that my sister's website doesn't have to do all of this management of all the things that might want to integrate with it. So imagine that she's got this toast sitting on her Windows machine. It would have to be polling the Google website constantly in order to make it be very responsive. Or it could sit there and park a request, but you get the idea that there'd be a bunch of work to go to do that. And similarly, if I used a Comet or Meteor style technique to update the web pages, I'd have to do the same kind of thing. So let's just see this thing now work in operation and connect up with a couple of things like Toast and so on. So I'll save this. Let's send it back up to Google. So I'm going to update the Google site, Google App Engine. So I'm just using their standard development environment. It's now posted up there, ready to go. And I'm going to do one more thing, which is I'm going to bring up both a web page. So let me minimize that. And I have a little web page, which is your standard Comet style Ajax web page that's waiting for notifications. And notice I've got this little notification icon down here. So I've got two different clients listening in to this notification. And so what I'm going to do is now go back over to my machine. So these are on different machines. I'm going to go to, oops, where is it? Here we go. That's the local host. We'll go back up to Google. I'll create a new menu. Let's create the pizza party. Save it, and let's get right back over to the demo, and let's see what happens. So the pizza party's been created, the notification's been posted, and if the demo gods all work, we should see momentarily an update occur. There we go. Our Comet app picked it up, and we should see Toast pop up here as well. Look at that. Toast is speedy. Well, I don't know why that didn't go, but don't worry about it. I think we're good enough. We've got the basics up there. So what we've shown is the service bus being used to do notifications. It put it out there on the web, and I'll kind of describe each of the pieces. So that gives you a kind of quick introduction to the two services, and I'll go through them in a little bit more detail. So this is what we just showed with the access control service. When we went to chefsinternational.com and we were trying to log in to the menu that we were controlling in step 1, Chefs International discovered that it didn't have the right kind of cookies. It's running on top of Google App Engine. It redirected to the browser, which then on step 3 sent it over to Chefs International. That web page was running on top of the access control service. It detected that it wasn't logged in. And so through a redirect through the browser, which I'm not showing, that's just the dotted lines, it bounced us over to Yahoo. We picked up the Yahoo OpenID using the standard OpenID protocols. We brought it back to the Chefs International login page. We ran the access control rules, step 6. We then sent it back to the browser, which sent it on in step 8, saying that we have the appropriate claims to go do the operation. And then in step 9, we got back the menu. So that's the access control service. And here's the service bus. The browser did a post up to Chefs International. Chefs International, in turn, did the post off to the service bus. and then we sent out notifications in parallel to a whole bunch of other systems. We sent it to the Ajax website and to the Toast, but Todd's up here going to go figure out why that didn't happen. Okay. Any questions for this kind of first part? Make sense what we're doing? See any requirements for Microsoft technologies in there? Does the fact that it's running on Google App Engine kind of help illustrate the point? Okay. Oh, seems like that was all pretty clear. Okay. So let me tell you how this is all coming out. We had our first CTP back in fall. In fact, some of this technology was around even earlier as part of the BizTalk services releases. And as we move through 2009, we're going to be constantly updating the services that are available up there today. And so some of what you saw is early examples of the kind of features that are coming online as we go through. Justin, Clemens, Yaron, and others will be talking about the forthcoming releases and how that all works. As we get into summer, we're going to announce the pricing and the SLA characteristics of the services, and then we expect commercial availability of the .NET services in fall. But the point is, you can use all this stuff now, and everything that you saw running was based on the live running services, and we're going to provide the sample code so that you can do exactly what we did up here. So this is all available, everything that you just saw. Okay. So let's drill in now to the service bus and into the access control service in a little bit more detail and talk about some of the kinds of things you can do with those. So the service bus. Well, the idea behind a service bus is that you want to make it easy and secure for partners to integrate with your application. We just showed this example of a very simple website, and something was happening on the website, new menus were being created, and we'd like to let people write their applications against that. And you don't always know ahead of time what those applications are going to look like, or how many they're going to be, or whether they're going to be disconnected or connected. Maybe they're mobile. And often, those partners and customers are going to be located behind firewalls or NATs where they don't have the kind of connectivity so that the notifications can flow from your application inside. A classic example is the CRM kind of applications. It's a hosted business application. You get some new customer. You want to send a message to the fulfillment or billing system so that you can send them a pamphlet. How are you going to get that message in through the corporate firewall in order to make that happen? So the approach that we've got is we're taking the classic pattern that works inside of most large corporations called a service bus, the enterprise service bus, and we're hosting it up in the cloud. And instead of using proprietary MSM or message queuing protocols or something like that, we're just using standard open internet protocols to implement the service bus. So what's a service bus look like? Well, here's the kind of pattern that you find inside of most service buses. There's a connectivity fabric that ensures that messages can be sent around reliably across firewalls and NATs, whatever it happens to be, as well as it ensures that we can get those messages delivered in a kind of timely fashion and so on. We also have a set of patterns that are built on top of that, things like the pub-sub messaging pattern, so that I can send out one message to the service bus, and the service bus will take care of notifying many partners and in potentially even buffering those messages if those partners aren't available to receive it. And then finally, there's a directory, a service registry that applications can hook into so that they can find one another, do discovery, and change policies and so on. All of that needs to be hooked up into an identity and access control service, and collectively, those things make up a service bus. Now, once you've got a service bus, you can connect it to a lot of different stuff. You can plug your services, in this example, our little menu system, into it, and then you can have lots of different clients that are listening to messages that are flowing through the service bus. So we saw an example of a website that was doing the comment behavior against it. We could have desktop applications. We could have Silverlight or Flash applications. We could have Toast all listening to messages that are out there on that service bus. Another thing you can do with a service bus is you can connect in enterprise service buses that are on premises to that internet service bus, and then all of the corporate services that are inside of a corporation can be exposed out onto the service bus, moderated by the identity and access control so that everything can be fit together. And then now as we're moving into the cloud services, those cloud services themselves can also be attached to that service bus. So you can find billing and storage and compute capabilities all through this one common service registry and the connectivity fabric. So no matter where the clients are, no matter where the capability is running, whether it's inside the firewall or out, we're able to get the messages to those parts of the applications, hook it together securely and safely. Once you've got that in place, then it becomes much, much easier to build new kinds of applications, workflows, and other kinds of business activities on top of that. And so that's what we see up in the top part, the blue pattern. So that's the basic model that the service bus provides. And if we looked in the features that we're providing with our hosted service bus, in terms of the connectivity fabric, I mentioned that we have the NAT and firewall traversal. So that toast that's running at my sister's house is sitting behind a firewall, and yet we're able to send messages from the application hosted at Google App Engine in through the firewall and go listen to it. As clients move around, whether it's on a mobile device or as people go in and out of connectivity because of network partitioning, we can support those intermittently connected scenarios. We support a wide range of application messaging patterns. So, for example, we can enable this bidirectional communication even though we're behind a firewall. We also support peer-to-peer. So we'll assist in communications being established, but once the communication's established, all that traffic can occur directly between the endpoints without any charges being incurred up at Microsoft to use these kind of capabilities. We talked about publish and subscribe. We can create a name up in the namespace, and we can send messages to that, and then people can listen on that message to make it happen. And then finally, we can add different kinds of policies to those messages, things like making the connections more durable so that if a client isn't available right now, it can come back at a later point in time, pick up the messages. So what people often refer to as queued patterns. The service registry is that directory. We can attach services. We can discover things. We support Atom Pub and a bunch of mechanisms on top of that. And then finally, there's a workflow capability. We can create workflows on top of the service bus that use certain activities that are designed to work with the service bus. For example, we can look at a message. We can decide if a message value is too high or too low. We can fire new events onto the service bus. We can transform the message and send it on. We could send mail. We can pick up information out of storage systems like the Windows Azure Storage or the cloud database technologies that we're producing. All of those things can be scripted to enable a lot of different kinds of activities. So just to give you an idea of the kinds of apps that the service bus enables you to build, let's just do one quick, simple example of creating a custom instant messenger client. And this is a sample that's available in the SDK. And in just a few lines of code, we'll create something equivalent to an IRC-style communication system. So before I do that, any questions on the service bus capabilities? OK. So what I'm going to do, let me just minimize all these windows. I'm going to bring up Visual Studio and take a quick look at the multicast sample. Again, this ships in the SDK. And what we see here in front of us is a few lines of code that provide a very simple chat capability. What we're going to do is let's take a look at the contract, the actual service itself. And all this service is going to do is it's going to get calls to things like the hello operation with a string, which is the person's nickname. So when someone joins a chat room, we'll write out nickname joined. We'll also have chat messages where nickname and string will show up. And then finally, they can leave the chat room. So there's a couple simple messages. And if we looked at the program, what we're going to do, and this is very standard Windows Communication Foundation activity. I'll show you where the one sort of interesting place that we do something different is. We go create what we call a channel factory. This is going to create channels up to the chat room. We add some credentials to that channel, so the username and password that we're going to be using to log in. And then we're going to go create a channel to go talk to that chat room, and we'll open it. And if you were to look at just regular old .NET communications code, this would look very, very standard. The only thing that's a little unusual about this is that more than one person is able to attach to that channel, which is how we get the multicast kind of capability. And what we're going to do is we're going to just sit in a very simple loop. We're going to first announce that we joined, and then we're going to sit in a loop. And as we get lines, we're going to pump those lines out and say that they're a chat based on our name. And then when we're done, we're going to say goodbye. And that's kind of it. That's an IRC system. Now, if you were to look at real IRC, there's a lot of code there. They got to get across the NATs and firewalls. They have to have a directory. All of that stuff is being handled by the service bus. And in particular, if we just were to scroll up a little bit, we can see where we create the name of the chat room. That's just creating a URI up on the service bus that we're all going to listen to. So let's actually see that in operation. So let me start up one of these things. And we'll call it MIX. So here's a little chat session. And we'll start one called shoe demo. Type in my password. And now we've got one member talking. So it's going up to the registry. It's creating the name up on the service bus, assuming I typed in my password correctly. And so we've got one now. Let me go add another one. And we'll call it Mix. And, oh, looks like Todd just joined as well. Let's do shoe development. And so that one's joining. Oh, I typed in my password wrong. That was dumb. Let's see. Well, we'll ignore that one and just keep going on the other one. I think that works. Oh, I love toast. Did you get your toast working? Okay. So as you can see, hi, Todd. We're chatting back and forth. And, or no, maybe I need to make sure that this thing is running. I'm going to ignore that. Wow. Let's see. Hold on. Let me just ignore this one. This is the problem with running multiple in there. I'm going to restart it. The problem with typing in passwords wrong. Is that one working?
Yeah, it's taken a long time to log in.
Yeah. Let me...
Did the same thing to me, but eventually it comes through.
Okay. Oh, there it is. Okay, great. And now let's see the chat work. OK. So you get the idea. There's a quick chat session, multiple clients running on different machines, behind firewalls, behind NATs, in corporations, all running in just a small number of lines of code showing how these things can be put together. So that's the service bus. Let's talk about some of the things that you might do with the service bus. You could create, as we just talked about, an instant messaging application with a pretty small number of lines. You can pop a toast. You could slingbox videos from your home. People know what slingbox is? It's a program, it's a box that you can buy that takes output from your video recorder, puts it out on the internet. One of the keys there is that you need to make sure that you can punch a hole in the firewall safely so that only the clients that you designate are able to go look at it. So we've got that kind of capability. Let's say you wanted to do easy, secure sharing from a mobile device. So from your laptop, you might want to put a website out onto the internet. And as you move from Wi-Fi connection or around between buildings, you'd still like people that are able to hit the website to get the messages, have your website display. That's a very easy thing to do with the service bus. In fact, we have samples showing exactly those kind of things. So one of the samples in the SDK is a simple file sharing system, all based on the internet service bus. Finally, a big use of this is to integrate with corporate billing, fulfillment systems, and other corporate resources, and then to do things like workflows to orchestrate the behavior on top of those things. So a great example of the kinds of things we see people doing, they take a workflow, the workflow periodically pings the corporate resources. If those resources aren't responding, then the workflow up in the sky does a notification that says, hey, there seems to be some sort of problem, and it can kick off other workflows in turn. So that's the service bus kind of in a nutshell. Clemens Vasters, who's back here, you want to raise your hand. He's the program manager in charge of that. He's going to be going through all of the rich sets of capabilities and showing a lot of the different kinds of things that we can do with the service bus at 4:15 today, I believe it is.
I think that's true.
Yes, this room. OK, so let's talk about access control a little bit more. As we talked about, one of the things that we see happening in the world today is more and more identity providers cropping up. We've seen Google, Yahoo, Facebook, Live, and others all announce support for OpenID. We've seen corporations start to put technologies like the Active Directory Federation server or the Tivoli Federation technologies out on their corporate firewalls so that they can start to integrate their corporate identities into applications so that they can do things like share benefit technologies or what have you across different partners and so on. So as we see all these different vendors and we see all these different kinds of technologies show up, it becomes challenging inside of your application to be able to integrate with all of those things. Even take OpenID as a nice protocol that's making a lot of progress. The difference between the way Google does it and the way Yahoo does it and the way Microsoft does it and the way Active Directory Federation server does it, they're all a little different. And so if you wanted to have inside of your program all of these different technologies, if you wanted to integrate with Facebook as well, it's going to be hard. The other thing is that if you have access control checks throughout your application, then changing things or understanding whether your application's in compliance or is structured properly gets to be pretty tricky. If you're checking, for example, whether somebody is your friend at Facebook here and then over there, that gets to be a hard problem. And many of these applications get brittle as you start to put them together. So our approach, pretty straightforward. First, we're building integration with a lot of different identity providers. We're writing that code. We're testing it. We have teams of people, for example, testing against Tivoli, against the Active Directory technology with Facebook, and so on. And we're also making that pluggable. So if you've got a favorite identity provider that we don't support, Justin, in his next talk, will walk you through what it's going to take in order to go add a custom identity provider and do the communication to the access control service. The second thing that we enable you to do is factor out the logic that's inside your application that has to do with access control into rules that you can look at, manipulate, report on, and so on. That means that all that logic is no longer mixed in with your application in much the same way that we've done this with databases. If you think about what databases did, is they took a lot of the logic that was written custom inside of an application, and they allowed you to embed it into databases, into stored procedures and other things so that it could be managed, reported on, maintained, and so on. We're taking that same kind of approach with access control technologies. So here's the basic pattern. Just like we have a pattern for the service bus, this is the basic way that people use access control. At first, what you do is you have the relying party and the access control project exchange some kind of secret. That could be a cert. It could be a custom symmetric key. And we're going to use that to decide whether or not the incoming claims from the access control project, the tokens that it issues, whether or not we're going to trust them. So we do a setup process where we go and exchange some secrets. And then what we do is we go write the rules. We write rules like John at Yahoo gets the ability to go view the information. Then in operation, what happens is that the user application picks up the tokens, and it takes those initial claims, and it passes them up to the access control project, which takes the rules and maps the incoming claims to outbound claims. And then it packages those things up in a return token that it sends back to the application, and that return token is then included with requests that are made to the relying party. The relying party then checks those claims. That involves a couple different pieces. You're going to want to make sure that you have the right kinds of permissions, and you're going to want to make sure that those permissions are signed by the secret that you exchanged in step 0. There's usually a couple more steps involving making sure that they're issued within a reasonable amount of time. But that's the basic approach that all of these things use. Now, we saw this in operation when we did Google App Engine. Our code was very simple. It looked to see if we had the incoming claims. If we didn't have them, then we redirected the user application, in this case the browser, off to the access control service, which picked up initial claims from Yahoo, did the processing, and returned it. Pattern make sense? So I've got a quick example just showing in code how we provide this capability in a pretty easy-to-use form. This is new technology that Justin's been working on. He's going to go into this in a little bit more detail. But let's open that up and take a look at his example. So we'll close the multicast solution, switch over to D. And this is a very simple calculator service. And the first thing I want to look at is the calculator service itself. And a lot of this is just about setting up the initial conditions. What I really want to focus on is this last line down here, which is service host.authorization service authorization manager. This is a standard way on the Microsoft technology stack where we're having a service host. That's the thing that is running the incoming service, in this case the calculator. We have a hook, a way to add to that something that looks for authorization checks. And so that's just all standard stuff that's been shipping for a while in .NET services. In .NET. And what we've added is a new thing, and that's this action authorization manager. And all that's going to do is a pretty simple thing. It's going to check for incoming claims where the claim is name of the service contract, name of the operation, issued by Justin's demo account. So if Justin's demo account gives us a claim that says this operation and this action is allowed, we'll let it go through. Otherwise, we'll redirect them off to an appropriate place to go get the claims and log in or whatever it happens to take. Notice that we're not doing any checks for Facebook. We're not doing any Google OpenID or Facebook or Live ID. None of that's happening here. All we're doing is saying, hey, is this operation allowed? That's all that has to go on inside of the code. And here's the even more amazing part. We're not writing it on any method in particular. We're just putting this blanket statement across all the operations of our service, saying, let the authorization manager handle it for us. So it really, really radically reduces the amount of coding that the developer has to do to get their application to be able to be managed in a good way by the access control service. You set this thing up once, and now everything can be managed externally by this account where an administrator can go set up those rules. So that's the first part. I think that's a pretty interesting little thing. Let's take a look at the client now. And on the client side, there's really two interesting things to look at. The first is that when we did this sample, we're not using a username and password. We're not using the classic way that people typically bootstrap identity. What we're doing is we're taking a cert and we're signing that a set of claims from this application. This is what we call a sort of self-issued capability, and this gives us a lot of flexibility around the way this client's going to behave. And then we've got two interesting new pieces here. One is that we create a token client, and what that is that's the piece of technology that talks to one of these security token services, like the access control service. And what it's going to let us do is send up an initial token and get back tokens. So it's a client of a token service. And what we're going to do is create some new claims. In this case, we're going to create the claim that this is the Justin calculator demo. And then we're going to use that client that we just created to send it up some initial claims, and we're going to get some claims back. And then we're going to attach those claims to the outbound proxy that is the calculator service. So that's all there really is to it. Create a claim, create the claim, package that up as a token, send it up to the access control service. We get back our access tokens. We then include it in messages, and our code is off and running. So it becomes a very easy way to interact with these security token services. This one happens to be interacting with the hosted access control service that we have. But the model is that any token service, whether it be Tivoli, Active Directory, Google, any of those different kinds of things can be used in this same way. And I think you're actually showing interacting with OpenID and Google in the next session. So just to kind of prove that this thing all works, let me start up the service. And so the calculator service is all ready. And then let me start up the client. I'll start up a new instance of the client. Let's see. There's the service running. There's the client. And it was able to perform that operation. And again, what it did was it went up to the access control service. Justin wrote the appropriate rules. He'll show those. And that enabled the whole system to go through. Again, just a few lines of code to be able to do these interactions. So what can you do with an access control service if you've got one? It actually gives us quite a bit of capability. The access control service has a set of interfaces that allow you to programmatically manage all those rules, all those scopes, to delegate permissions on those things, and so on. So here's a concrete example of the kinds of things I might do. I could implement an RBAC, a roles-based access control model, using the access control service. I could say, for example, Bob is in the role manager, and managers have the edit permission. But I can go even further. I could say Bob's a manager, managers have edit permissions, and edit permissions mean that you could call these specific operations, and we could use that authorization manager that we just looked at. So we can chain rules. We can build pretty sophisticated access control policies, all with a set of rules. Not only that, but we can share those things across different scopes and so on, so that we could build up pretty interesting models. Another thing that we can do is we can use the access control surface itself to manage permissions to modify the rules. So that's kind of a recursive thing, but that gives me a lot of capability to do delegation. So for example, I could, in my menu, give my sister permission to add people to who can look at the menus. So I could have friends have the ability to invite friends. I can control the permissioning on the scopes and so on. I can do that both manually by going through the user interface, but more importantly, I can use the programmatic interfaces, the Atom-based interfaces to the access control service to do that. And we're going to, in fact, see a demo that Todd's going to do in a few minutes that shows some of that in operation. So if you've got all those capabilities, here's a couple of the sort of fun things that you might think about doing. As you saw in the first example with the menu, it just takes a few lines of code to go take an existing website or an existing application and go add access control to it. So you could imagine taking a Warcraft guild page that's written in PHP, adding a couple lines of redirect, and now you've got your friends at Facebook or Yahoo able to see that private page and manage it. You might also think about something more sophisticated. You could take that same approach, extend it a little bit further, use that delegation capability I talked about, and build a system that would enable you to sell ads into games and then sublease who can display what in that ad space. So you can imagine going through a racing game and having screen real estate, which is on the sides of buildings, that people in turn are selling to other people. You can give enterprise users access to Python-based training applications and let those corporate users come in automatically because of the federation that we support with corporate identities. You can generate reports. You can use those programmatic APIs to generate reports about who has access to what kind of roles can do certain kinds of operations. Very important in corporate activities where you have to be Starbucks compliant, or it's important in certain pharmaceutical and other kinds of industries that they know who has what to certain kinds of information. And finally, we talked about this delegation capability. You could give friends permission to let their friends access the party photos. So all kinds of quick things that you could go do with the access control service, and they don't take a lot of effort. The access control service is a pretty powerful thing that lets you put these kind of applications together in a pretty straightforward, pretty easy way. Justin will be talking more about that. Okay, so we've got about 20 minutes left, and I've got two pretty cool demos. We've got one demo that Dan's going to do. Dan's an ISV, and we met in Redmond. Why don't you come on up? And Dan was building a solution based on Azure called Scrumwall. And what Dan's going to do is he's going to first describe the application. And that application's a pretty sophisticated Azure application, runs on top of Windows Azure for scale out and a bunch of other things. And he's going to walk us through that. And you might, as you're going through it, might be wondering, well, where is it using service bus and access control and all that kind of stuff? And once we get to the end, I think it'll be pretty apparent why that ends up being a big deal. So welcome.
Cool. Thank you, John. Good afternoon, everyone. I'm Dan Scoff. I'm CEO of .NET Solutions. We're a software development company from the UK, as you can probably tell from my strange accent. As you can probably tell from our strapline, we're quite big into agile development. Does anyone here use agile at all? A few people. Anyone use Scrum? Okay, most people. So for the benefit of everyone else, agile development is all around taking big projects and breaking them down into a series of smaller projects, which we call iterations. And in Scrum in particular, one of the central parts of it is the Scrum wall. Now, traditionally, a Scrum wall is a set of post-it notes stuck onto the wall that you move around as a visual representation of progress on a project. Now, the problem with post-it notes is they have a nasty habit of falling off the wall, and the cleaners clean them away, and it all gets very messy. So we thought, well, wouldn't it be neat if we could do a Silverlight version of the Scrum wall that you could manage your projects through? So what I'm just going to do is go ahead and open up a browser. Focus across. Now, I was nervous before I came on stage. The demo gods we've obviously angered somehow today, so I'm even more nervous now. But hey,
well, I told you we were using a lot of crazy stuff.
We are, yeah. So I'm just going to go ahead and sign in here. Okay, first test worked. We logged in. So this is now just going to go ahead and fire up the Silverlight application. So the first thing we do is we come in, and we're going to go ahead and create a new project. We're going to call this Mix Demo. The business sponsor is me. Mix Demo. And we're going to start it next week. So I'm going to go ahead and save that. So I click on here. And I can go ahead and launch the Scrum wall. So those of you familiar with Scrum will kind of recognise this. We've got our backlog on the back, which is all of the stuff that we're working on. We've then got the sprint, which is the current things. And then we can move the tasks over to the right as we go through it. So I'm just going to go ahead here and create 3 new stories. Start here at the bottom, and let's pretend we're building the Scrum wall itself. So as a user, I want to... Can't type. Create stories. Put here.
Now, as you're typing those things, all of this stuff they have running up on Windows Azure, so as a hosting platform. They also can use the local development environment to run that.
We can indeed. Unfortunately, it doesn't get along too well with my netbook, which is a little underpowered. So we have a local version of it running, but the production copy of it will be running up in the cloud. What we can also do, which is quite nice, is this is designed to run on smart boards, which you might have seen. So I can actually just type directly onto here. But my skills of using a mouse to type are not particularly good, but you kind of get the idea. So what I can then do is I can then take those stories and I can move them across into the sprint. And I can then go ahead and I can start to create tasks against each of these. So I can go in here, I say, write some code, and then write some more code. Can you tell I'm not that technical? It's magic stuff that these developers do. And then as we're actually going through and developing the project, I can actually then move them across into the work in progress. And then as we complete them, I can move them across into the done pile. So this is all quite neat, kind of standard stuff, Silverlight application, talking to a database. So why am I here talking to you in a .NET Services talk? Well, this is where it starts to get a little bit more interesting. So what I can do is I can go ahead and just open up another copy of that. And just for fun, seeing as we're in Firefox mode here today, I'll open up a copy of Firefox as well. I'm going to have to log into this one again. And then what's really neat is you can see here the second window is immediately synced up, so I've got my stories appear on there. And then when I open up this third window in a second, you should see that one sync up as well, as indeed it does. So if I can use my real estate correctly, what I can then do is I can then go ahead and make changes on any of these browser windows. So new task, for example. And you see it then immediately syncs up across all of the other browser windows. I can move stuff across as well. And again, we get that message pushed down into the two browsers. So what's actually happening here is we've got a pub-sub model, as John explained. So each of these browser instances is subscribing to messages on the service bus. Whenever a change is made to any of them, we're then posting that message up onto the service bus, which is then pushed down to all of the other browser instances. So why did we pick .NET Services for this? Well, the original version of the application was using the Meteor pattern, which, if any of you are familiar with direct push, is all around opening connection up, waiting for the data to be received, and then returning that. Because we didn't want to have polling. As John said, you start killing your bandwidth, and it's just a nasty, nasty way to do things. We've got Silverlight available to us, so obviously we have the ability to use sockets if we'd have wanted to, but then again, you hit all these nasty problems with firewalls, and this is all hosted up in the cloud, so people are going to be connecting to it remotely. We didn't want any of that kind of thing. The final problem is scale. Whilst the Meteor pattern would probably work for hundreds or maybe thousands of users, you start getting hundreds of thousands of users with millions of messages getting pushed backwards and forwards, and we just couldn't guarantee that all of those messages would be delivered to all of the different browser instances. So that's how come we picked .NET Services. So obviously we have the scale. We've got $5 billion worth of servers up there at our disposal that we can use to route all of these messages around. But the other really neat thing is that we can connect up to on-premise applications. So one of the other things that we're doing is we're working with the Visual Studio 2010 development team to hook this up to on-premise Team Foundation Server. So actually, when we're moving these Post-it notes around, what we're actually doing is updating the status of work items effectively. And we want those statuses to be pushed down into the local Team Foundation Server so that when you move them around, that status is updated. We also might want the ability that when user stories are complete, we could get Toast popping up on executives' desktops to let them know that the development team's actually doing something and all this kind of thing. So it opens up a whole range of new possibilities to us, and it's been fantastic to work with.
Great.
Cool.
Hey, that's super cool.
Thank you very much.
So I think that's a great example of using the service bus to build out these scale applications, to provide integration with backend systems and so on. What we wanted to do is take a look at another application that Todd has been working on. Todd's a member of the CSD technical strategy team at Microsoft, where he's an architect and program manager. And we've been talking to Netflix. And why don't you tell us a little bit about what's been going on there?
So Netflix has a really nice developer API. I don't know if any of you have had a chance to look at it. But one of the things they want is to make sure that their content is more broadly available on the internet so that people from other social networks will encounter their Netflix content, be able to interact with it, and be able to get introduced to Netflix without necessarily having to come to the Netflix website to do that. So as part of thinking about how .NET Services could help in that process, we put together a website called cinemamix.net. So if you could switch me over to my...
Sure, there you go.
This is cinemamix.net. Let's imagine that I'm a movie enthusiast. I've got a group of friends that I regularly get together with to see movies. And I want to share my Netflix queue with my friends. I want to give them a chance to come in and see the Netflix queue, maybe comment on it, possibly edit the queue themselves. And that's what we wanted to do with CinemaMix. So the key functionality that CinemaMix provides is not just this interaction with Netflix, the use of the developer API and the other queue sharing capabilities, but also we want to be able to control the access that we give to our friends when we invite them in to look at the queue. So that's where the .NET Access Control Service comes in. If you look at the screen, you can see I've got my Netflix queue, and I have the ability right here on CinemaMix to sort the queue. I can move movies up and down in the list, and this will actually change the order in which Netflix sends me the films. I also have the ability to delete movies from the list and in other ways edit the list, and that's actually going against my direct Netflix queue. But over on the right, I've been able to invite some friends. This is the cool part of the site that we wanted to show. I've got a few friends that I've already invited in. I've given a couple of them view permissions, and maybe I don't want everybody to be able to actually edit my Netflix queue, but I may want someone to be able to do that. So I've given one friend edit permission. How did I do that? I just clicked on the Add Remove button, and Cinema Mix is going to refer to a list of social networks that I belong to and pull up my friends lists on those social networks. So you can see here we've got Facebook, Windows Live, and MySpace. What we're looking at here is my friends list on Facebook.
And this is all running live against Facebook?
This is running live against Facebook.
Okay.
So let's say I wanted to add a new friend to be able to view my Netflix queue on Cinema Mix. I just click on my friend's name, hit Done, and behind the scenes here, Cinema Mix is making a call to the access control service to insert one of the rules that you've already seen a couple of different times now. This rule is going to say that this individual on Facebook has the right to view my queue on Cinema Mix. And there she is.
So just to kind of summarize what happened there, we went to Facebook. We used the Facebook picker to identify Facebook identities. We then turned around and used the programmatic interfaces to the access control service to go create rules that indicate that this individual, in this case, who was it? Gwen, has the ability to view. And we could go and use the drop-down, change her to edit, and that in turn would go make additional modifications to the rules for us. So in addition, it did one more thing. You added a
Yes. The other thing we did is made a call to the Facebook API to send Gwen a notification so that the next time she logs into Facebook, she'll see that she's been invited to come and view my queue.
So this really addressed the business need that Facebook, that Netflix talked to us about, which is they've got this super cool API. They wanted to get people in all of these different social networks to start interacting with their site. And so what we've been able to do now is pull in Gwen from Facebook into the Netflix experience. Now, here's what's really interesting. Gwen can actually now log in and start
let's take a look at
stuff.
what she sees when she logs into Facebook first. So the next time she logs into Facebook, it's her Facebook homepage here. In the bottom right-hand corner, she's got a notification. It's a little red flag that pops up and tells her she has a message. So this is me impersonating Jason Alvarez, otherwise known as Skraling. And I'm going to see in this message a link to cinemamix.net and the guest login page. So she's going to actually be able to just click from there into CinemaMix and see my queue. And what's happening now is she's being redirected over to CinemaMix, and the site is smart enough to know that we've invited her through Facebook, and therefore it's going to throw up a Facebook federation button. And what she has to do here, if she hasn't already logged into Facebook, she would have to supply her Facebook credentials. In this case, she's already logged in, so there's already a cookie on the Facebook domain showing that she's logged in. And so instead, what we're going to do here is just click on this button. What's happening there is we're giving CinemaMix permission to validate our Facebook identity and to show this content. So now we are looking at my queue as Gwen. You can see she just has view permission. She can't change the order of items in the list. She can't delete items the way I was able to do.
So I think one thing that's interesting now is let's go back and look at the access control project and see what was programmatically added to this particular queue.
So here are the list of rules, and I just need to refresh it, and then you'll see the rule for Gwen pop up. There she is at the bottom with view permission. So just to prove that the access control service is doing its job, let's go in and change that to edit. You've seen this a couple times. Hopefully you believe this works by now. And all we have to do is go back to the guest view page and hit refresh. And now CinemaMix is going to do what it did the first time she came in, which is to make a call to the access control service and ask if she has any permissions for this particular application scope. And if so, it's going to open that up. And based on what it finds there, view or edit permissions, it will change the behavior of the site. And so here we see now she has the ability to move items around in the queue. She can edit my Netflix queue, remove items from the queue as well. And if we had Toast working, you'd also see a Toast message pop up here. But unfortunately, my Toast program is Toast.
Okay.
Sorry about that.
Question?
I'm just lost on the button needed to reestablish with Facebook and the first time it came in here. Why is that necessary? Couldn't that be done behind the scenes?
So what in Gwen's case, right? Gwen's coming in. She's got so first Jason set up his queue. Gwen got the notification that she's allowed. So she clicked on the link. That brought her over to the Cinema Mix site. She hasn't yet gone through the normal process that any of these federated identity providers have of asking Gwen the question about whether or not she wants to give that other application the permission to use that identity, because we don't want arbitrary websites grabbing your identity out of Facebook. So that's what Gwen did. She said, yes, it's me. She logged in. That gave the permission to go through and provide that OpenID credential to Cinema Mix. Cinema Mix then used that to look into the permissions and display the appropriate information. Does that make sense? Okay. Yep.
When you go to Cinema Mix for the first time, do you log in with your Netflix user ID?
There was an initial setup where we used the OAuth protocol with Netflix. So when Jason set up his Cinema Mix account, he could come in from anywhere, but he has to get Netflix permission to let Cinema Mix access his queue. And that's where OAuth was done. So we had already set that up, and then what we're showing then is the subsequent actions where Cinema Mix is picking it up.
And once that happens, then Cinema Mix has a long-lived token and can go back and do that in the future without having to separately.
And it talks to Netflix APIs and protocols.
Yes.
Yep. Okay, so just to quickly wrap up, as we talked about, this is, these technologies are in CTP now. You can go and register for a free Azure account. Go to www.azure.com and get this stuff. To learn more about the .NET services, access control, Justin will be doing here next, this room. And then following that, Clemens will be talking about the service bus in more detail. There's evaluation cards. We'd appreciate it if you could fill them in. And we've got a couple more minutes for questions. So there's a mic up here, and Todd, Dan, Justin, Clemens, and I are all available if people have questions. So any questions? So thanks.